Not to close the doors to get some level of air in, and we'll see what happens with that. We'll close them if we have to. So, hello. How many of you have been in here the whole day and seen all the talks? Okay, that's how you got your seats. Understood. I'm Magnus Hagander. I'm here today to give a talk about what Postgres 9.4 looked like 3 days ago. Things have happened in those 3 days, and I haven't updated everything. But it'll look at them approximately as what they. So, as I said, I'm Magnus Hagander. I'm a Postgres core team member and one of the committers who has not done as much work as he should have on Postgres 9.4. Other people have pulled more of the weight this time around, but that's to be expected sometimes. I also work in Postgres Europe, which is why you'll find me a lot over at our table in the AW building. If you haven't been there yet, come look at our merchandise and talk to us, ask questions, such things over there. When I'm not working on community Postgres, I work for a company called Red Pill Info in Stockholm, Sweden, where we do sort of generic open source consulting where, well, kind of obviously my focus is Postgres. That's why I'm there. So let me start by actually going back to the first slide and say, so Postgres 9.4. How many in here are already running Postgres 9.4? That is surprisingly many. 9.3. That's nice. 9.2. Okay. 9.1. 9.0. 8.4. Okay, you guys have work to do. Postgres 8.4 is end of life in June this year. You need to upgrade by then. 8.3. Okay, you're already screwed. 7.4. Okay, that's some point there. But in particular, those of you who are on Postgres 8.4, work on it. Like, start working on it now. Because come June, you will no longer get any bug fixes or any support on that product. And there are a lot of people who are still using it. So definitely look at that. But today we're going to talk about Postgres 9.4, which is somewhat newer. In fact, it's not there yet. As most of you probably know, Postgres 9.4 has not been released. It's the upcoming version. Greenplanet.postgres.org. Okay, for the rest of you, if you'd actually done that, you wouldn't have to come here. Planet.postgres.org is the Postgres blog aggregator, and there are a couple of people there who have done a lot of blogging about the new features, mostly from a very technical perspective, but they basically take the commit message, read it, and then translate it into something that other technical people can understand. In particular, we've got Depeche and Michael Paquier have written, they've each got their own series of, I think they both call them Waiting for 9.4, which is every time a new major feature gets there. So I've stolen a bunch of things from them, because that makes life easier. And of course, thanks to the guys who actually wrote all these features, because there's quite a few things coming in. But first, where we actually are with Postgres 9.4 today. Some of you may be familiar with the terms and the cycles that we use for Postgres development. We typically aim for a release once every year. We branched off Postgres 9.3 on June 14th last year, and that's when the master branch became what's now turning into 9.4. And we opened it up for development of new features. And in Postgres, we work with a cycle based on what we call commit fests, which is basically we take, I guess the original idea is we take a month to do development, and then we take a month to review and commit that work, and then we take a month for development. We actually manage to stick to that schedule. We're never finished in 1 month, and they overlap and cycle, but that's sort of the basic cycle that we're working on. So we've been running 4 commit fests per release, typically. We've got one in June, one in September, one in November, and one that starts in January. And I think we've started all of the commit fests on time and not finished any one of them on time this time, but that's fairly common. And in particular, the idea with the January commit fest, which is where we are right now, even though we're now in February, as you all learned when you got your mailman reminders this morning, is the January one is expected to take more than a month. Because if your patch does not get reviewed and committed in the January commit fest, you are not going into 9.4. So the status right now is we are in this final commit fest. We started it on January 14th, so we've been going it for a bit over 2 weeks. And we're actually making good progress when we look at the number of patches. I think almost a third of them have been handled. Of course, we've handled the third of them that's easy and fast. And many of the big ones are still pending. But the idea with this one is it continues until the end. So if you have some spare cycles, in particular if there's stuff that you're interested in, there is a web application at commitfest.postgres.org where you can get a list of the pending patches, and if you're interested, download it, apply it, test it. Just applying it, making sure it builds, still helps. And just post a report to the mailing list saying, I tried this, or I applied this patch, I tried to run the query, and it segfaulted. People want to know that. That helps everybody with the development, so that we can actually get 9.4 out. I always tend to do these statistics views because you can get interesting stuff out of Git. We're currently at approximately 2,000 files changed in 9.4, 81,000 insertions and 55,000 deletions. This is actually significantly lower than 9.3, which was a little bit lower than 9.2. But as we all know, line count is the best possible way to measure developer productivity, right? Line count is important. There are some pretty major things, and also we're less than halfway into the final commit fests. There are some fairly large patches waiting, so well, it shows you there's a lot of work already gone into 9.4, and of course there will be more of it. So I always try, I do this talk for every version, and then I try to figure out, let's categorize all the things that I'm talking about into groups, and then I fail. Because it's pretty hard to actually try to find groups for them and then fit things in. 1 year I only managed to find 2 groups. I think it was performance and other. So it's kind of hard, but I've sort of done it so that we can go through a laundry list of some of the things that are in. Obviously we can't cover everything in just 45 minutes, but some of the major features, some of the minor features that may make major impact as well. And I've grouped them into sort of developer and SQL features, and of course that's developers building against Postgres. We don't cover too much of the backend things. We got infrastructure, which is for developers who are building Postgres, or who are building extensions into Postgres, so sort of the more core level. DBA administration thing, it's all a bit blurry. And we're back to doing some replication and recovery stuff. 9.3 was a very unusual version in that we didn't actually have any major replication features in Postgres 9.3. We've fixed that now. We've added some more stuff. But let's start at the beginning with developer and SQL features. Actually, let's start by, so how many of you would consider yourself a developer using Postgres? And more of a DBA administering Postgres? Why are the rest of you here? What's left? If you're not developing and you're not administering it, and
staff,
marketing. Okay, so sort of developer, this is like the SQL level new things. We have some interesting new sort of smaller things. There's been a bunch of work around aggregates that will help a lot of people. We allow variadic aggregates. We don't ship with any. We've had the same discussion about other functions where we've said, we're not going to ship with them because it's really easy to get confused. But if you want to confuse yourself, go ahead. So what variadic means for those of you, so basically aggregates with a variable number of arguments. Right now you have things like string ag, which takes 2 arguments, the field and whatever separator you want. But you can now do a variable number of arguments. This is an interesting improvement of the explain plan that's actually very useful to have, which is you get the group key in your explain plans now, which you didn't do before. So you had to look at your explain plan and go like, oh, that looks like it came from, which of my group bys did that come from? Now it will actually tell you that. Very simple things that can help you read your plans a lot more. Something that's going to help you type a lot less is that we now have support for filters in aggregates. I'm sure you've all built solutions that is better built this way. You built solutions with lots of, select something and then case when something, then 0 or 1, and then summarize that. You can just say something like this. So count star filter where b is greater than 5 will then count only the rows where b is greater than 5. And of course we can combine multiple of these aggregates within a single group by. It's one of those features that seems really simple. I'm not sure why we didn't have it before, but I'm sure there's a good reason somewhere deep in the code. Very useful in particular about simplifying the kind of queries you're writing. Because it's quite often this that you actually want to do. count number of approved versus unapproved entries, things like that. And filter will make that a lot easier. Now we also have a very big change when it comes to aggregate. So how many people in here actually know what an ordered set aggregate is? So 2 of you, and you write books on this stuff, and you reviewed the documentation for this patch, I think. So yeah, I did. Well, it's sort of the same. I remember when I did this presentation about lateral last year. I didn't know what lateral was. I knew what it was. I didn't know it was called lateral. And it's sort of the same thing with this. I actually knew what it was. I knew we wanted it, but I didn't know what it was called. It is in the SQL standard, yes, as you pointed out. But so it's been there for a while, which is why I knew we wanted it, but I didn't know what it was called. So this is basically a new class of aggregates that deals with things like offsets inside of your group. The key syntax is within group, and we also allow for something called hypothetical aggregates. Some of these names are just fantastic, like hypothetical aggregates. It lets you aggregate on rows as what they would have looked like if they had been there. That sounds much less ordered set aggregates. So we say select A and we say mode something within group order by B. We always have to have an order by. This gives us the most common value in the group. So it gives us A, and for each A, the most common B. Can be quite useful. Actually, doing that today is much harder. You have to use a window aggregate and then nest it in a CTE and things like that. The other thing you get is you get access to percentiles. So in this case, you say select A and say percentile cont, and percentile disk is the continuous and the discrete percentile. So it looks which row is 30% into this group. So from the beginning, move 30% into the group. Which row is there? Again, this is something you couldn't do before at all. You had to get the whole set back and then try to reduce it. The hypothetical ones are possibly the most important ones. Select rank 4, in this case, says if there was a row that was exactly this far in, like in percent rank 4% in, what would it look like? Even if the row isn't there. So basically you take a range of values and you say, well, I want the exact center of it. You get that even if there's no row there. Well, it doesn't get you the row, it gets you the value that you would have had in that column for that row. And of course, they're all shown as aggregates with a group by. You don't have to do a group by. You can do it over the whole table. That's the same as a group by of nothing. Or you can have multiple levels of group by. And of course, you can combine them. Most of these can also be used together with a window function. I'm sure that's awesome. I haven't found a good example yet. But it opens up a new way of accessing things without having to read back the whole groups of data, either into your application or maybe into a stored procedure, and process it. Instead, you can just let the database take care of it. And that's usually a good thing. You move the problem to somebody else's problem. That's the whole idea of SQL, right? You tell them what you want and somebody else figures out how to do it. And hopefully they do it fast. And then we live in this imperfect world where we have to start tuning things. But in theory, we shouldn't have to do that. We have significantly improved the handling of updatable views. We support partially updatable views now, which suddenly makes them much more useful. So this is the automatic updatable views. You've always been able to do your own updatable views in Postgres by creating a bunch of rules. But in 9.3, you would get the automatic rules if your views were very simple, like select from a single table. But when you added things like a join, it rapidly becomes non-updatable because the system doesn't know which row in the other table that corresponds. What you'll get in 9.4 is you'll still be able to update the rows or the columns that are from sort of the master table, even if we don't know where the other ones are, because they're not affected by this. So we can update some columns even in the case where some of them cannot be predicted and therefore not be automatically updatable. So again, less manual rule writing. And if you need to update the ones that you can't define which they are, well, you have to start by defining which they are. There's no way the system can figure that out. We've also added something called with check option. Again, automatically updatable views that will have the view verify the value. So in 9.3, if you have, say, a view that's select star from my table where group equals 4, you can actually insert into that view with a value of groups that's not 4. And then you can't get the row back through the view, which may or may not be what you expected. If you enable with check option, it won't let you do that. So if you say with check option local, it will verify on that specific view, saying, well, if you inserted group equals 5, I'm not going to see that row, so you don't get to insert it. And we have with check option cascade, which will look at other views if you have nested views, and do the same thing. You will no longer be able to insert a row that you can't see. Now, sometimes you actually want to be able to insert rows that you can't see, depending on how your system works, and just don't specify with check option, you still have the old behavior. Gives you the choice of both of them. In sort of the aggregate style area, we've added multi-argument unnest. If you're working with a lot of arrays, it lets you unnest 2 arrays into a single table. Even though they're completely independent, this query will return you a table of 3 rows, one which is AD, one which is BE, and one which is CF. And obviously these doesn't have to be actual arrays, so it can be subselects or things like that that converts through an array. And you can also combine this with a keyword that's with ordinality. That means that for each row that's coming back from this unnest, PostgreSQL will just add the row number. It seems like that would be easy, but it's pretty hard to actually do that today. You have to create a temporary sequence and get the value out. And it's also quite useful, not maybe if you're just selecting this and reading it back into your application, because you can count rows. I'm sure you know how to do that in your application code. But if you're joining that with something else, then the ordering goes away. This way you know the original ordering, you get a generated column that you can then maybe order your final results by. Something like that. Let's get you up for that. How many of you like writing stored procedures in PLPGSQL? A couple of you. How many of you have had trouble debugging them because you don't know where in the call stack you are? Now you can have a stack trace. Get diagnostics can now return a stack trace using PG context, and that will within PLPGSQL. It helps when you do, like some of us like to do, and accidentally write infinite recursion and stuff like that. You can find out where it happened. Just a simple stack trace. There are some other improvements to PLPGSQL as well, but personally I find this to be the big one that we've had so far. It's going to help. So let's go into a few of the infrastructure things that you're probably never going to use. As in, you are not going to use them. Somebody else is going to use them and give you a nice tool. How many of you actually or the people in here have built a back-end side extension to Postgres in C of some kind? So I figured like 5 or 6 people in the group. Yeah. Well, this is for you. The rest of you can take a quick nap. We now have something we call dynamic background workers. 9.3 got background workers, which is just utility processes started by Postgres. But they all had, well, like we have already things like auto vacuum. We have things like the statistics collector. These are system background workers, basically. They could only be started with Postgres, and if you want to change anything, you had to restart the whole system. Now you can start them dynamically. So you can, for example, you can start them from SQL. You can have one background worker start other background workers. This is how auto vacuum works. So it gives you an ability to build more logic that runs basically on the server. Gets access to a bunch of these things. Alongside with this, and also very useful for these background worker things, is that we now have dynamic shared memory. The main Postgres shared memory segment, where we keep all of our buffer cache and those things, is still not dynamic. You still have to restart the server if you want to change your cache. Sorry, not yet. We might get there. But you can now allocate shared memory on request in these background workers. So background workers are actually able to communicate with each other in a much better way. So this is all about building an infrastructure that we so far have nobody that's using other than example code. But once it's out there, it provides an ability to write things as an extension that where you previously have to patch the Postgres source code. So hopefully people will find cool things to build. We also have a lightweight message queue that's built on top of this, so you can have a message queue between your background workers, for example, or between a regular backend talking to your background worker. Something that will affect you more, but it's really deep down just a code change. How many in here know what snapshot now is? So snapshot now is sort of a Postgres artifact whereby when we scan and use our system tables, we haven't been using MVCC, the multi-version concurrency control. We've taken a bunch of locks and we've had sort of really strange visibility rules for some of them. This has all now been changed and is now all using MVCC the same way as the rest of the system is. And snapshot now doesn't exist anymore, so if any one of you who put your hand up has actually built an extension that uses snapshot now, your extension will break, as in it will no longer compile. That's intentional because snapshot now doesn't exist. There are other ways to do similar things, but we wanted them to break so that you know that they've actually changed. It allows for simpler, more robust code. It allows for more code that's not specialized. There are a lot of code that had very specialized access paths for these system relations just to deal with the snapshot now. And in the future, and then that's an ongoing progress, it allows us to decrease the locking required for a number of DDL operations. Like less locking for an alter table. Today we still, we don't lock the table itself, depending on what you're doing, but we still lock the system tables. This will allow us to make less locks on the system tables and allow greater concurrency in things like DDL operations as well. Going more into the DBA and administration. So Postgres 9.3 added materialized views. How many of you are using them by now? Not many. How many of you are not using them because you can't refresh them without locks? Now you can. You can now do a refresh materialized view concurrently, and then the view name. I always put them in the wrong order myself. I'd personally say that the materialized view that we had in Postgres 9.3 were not very useful, particularly because you couldn't refresh them without an exclusive lock. So you couldn't even read them while they were being refreshed. Refresh materialized view concurrently lets you keep doing stuff. It lets you read them while they're being refreshed. You can only do this if you have a unique index on the view, because that's how we merge in changes that happen while it's being refreshed. Hopefully we may, at some point far in the future remove that restriction, but in fairness, unique indexes, we usually have those somewhere anyway. And once you do that, you can now refresh your materialized view without having any locking, without it blocking any of your other operations. You can set table space options when you create it. I really don't know why we didn't have this before. Previously, we wanted then do an alter table space to change it. Now you can specify it when you create it. A possibly more useful one, if you're actually in an environment where you're using a lot of table spaces, is that you can now move objects in table spaces, not just one by one. So if you had a table space with 100 tables and 1,000 indexes, you had to move them one by one if you wanted them to a different table space before. Now you can just say alter table space, move all over here, or move the indexes over here. Obviously, you can still move the individual tables if you want to, but this will let you move all of them as one big batch.
A database per schema per table?
Table spaces are cluster-wide, but obviously you'll need to be in the database that contains your table if you're going to move it.
Yeah.
Otherwise, we can't find out that the table exists.
Move all indexes.
Move all indexes because we can't see the ones that are in the other ones.
But just,
We don't know that they exist if they're in a different database. We'll notice when we try to drop the table space and it says, no, there's stuff here. You need to move it. Yes?
Move in parallel, do more thread, or is by one by one?
It is single-threaded. It'll be one by one move. You can probably do it multi-threaded on your own by basically doing alter table move, but this one will just do sequentially one by one.
Yeah. Because I think about when you have partition table, no, with a lot of.
Yeah.
And so okay.
Yeah, it will move them one by one.
Well, okay.
But you need super users.
We got a small simple tool called PG Prewarm if you need to pre-warm your cache. There have been other tools that can do similar things, like how many of you used PGF Incore, or however you're supposed to pronounce that? A couple of you. This is sort of does that. You get a new function when you install this called PG Prewarm, where you can say for this table, load it into the operating system cache, or set a read ahead for the operating system cache, or load it into the Postgres buffer cache. And it'll just read the data into memory and then not do anything with it. It's fairly simple, but it's something that might be useful if you're planning to do, say, a replication switchover. If you want to make sure you don't switch over to a cold cache, or if you're just bringing up a new node in a cluster, you want to make sure things are in cache before you put your workload on it. Because yes, the workload's going to put the things in the cache pretty quickly, but while it's doing that, it's going to be slow. So it's a fairly simple one, but it can help you out in a lot of cases. And unlike PGF Incore, it's platform independent, so it works on all platforms that Postgres does, except for the read-ahead hinting, which only works if your platform has POSIX advice, which most platforms except Windows has. I think Mac also doesn't have it, actually, but all the others do. We've added the ability to change configuration via SQL. You don't have to edit your config in postgres.conf anymore. You can now say alter system set, and that will change it for you. What it does is it puts it in a file, basically. There's a separate config file, so we will now have two config files for Postgres. There's a postgres.conf and there's a postgres.order.conf. This tool will manage one of them. So basically it just writes them there. It overrides whatever is in that file by default, overrides what you have in postgres.conf. So if you run an alter system set and you change it in the postgres.conf file, the alter system set will win. It does not change it immediately, so you still have to reload. Typically in this case, like what you hear with select pg reload conf, which will reload whatever's in there right now.
But you need to have super user rights.
You need to have super user to do this, yes. A regular user cannot do alter system set. That would be bad. The regular user for workmem, for example, the regular user can still just do set workmem for itself, but it can't change the system default. System default is super user only. Now our contexts still apply, so parameters that are set, for example, to require a reload still require a reload. Parameters that require a restart still require a restart, but you can't actually do the restart from SQL. So if you change, for example, say your shared buffer setting, you can change that with alter system set, but then you still have to do a restart of the service from the operating system Saha. And there are some tricky things. The big advantage of this one is if you, for example, put in an invalid value in many fields, you'll know before. When you just edit the config file, you put in an invalid value in workmem, and then you do reload, and you have to go check the log files and see what happened. Here, the alter system set will immediately give you the error. But in particular, when it comes to parameters in restart context, it might not know. So you can, for example, set it to an invalid size, but it's a valid number, but it just doesn't work, or it's dependent on something else that we can't see at the time. Then you do a restart, and it still doesn't come back up. So particularly when doing alter system set on postmaster context variables, you still have to be very careful. Just as careful we were set like your shared buffers to 8 terabytes on your 8 gigabyte machine, strange things will happen. You'll also uncover bugs in the code, because I used that as a test for this. In completely unrelated parts of the code, don't like shared buffers of 8 terabytes. Yes?
Where's that new config file?
It's in the data directory as well. So right next to the other one. Well, right next to the other one unless you're on a Debian platform, in which case it will still be in the data directory, whereas your main one will be in the etc directory. Because, everything else would be way too confusing if we had everything in one place. No. It can't be the same everywhere. That's boring. Couple of new important or less important, depending on your environment, configuration parameters. We have a separate parameter now, auto vacuum workmem. In previous versions, auto vacuum has used maintenance workmem. Problem being that auto vacuum can be used in multiple parallel sessions, which makes this a somewhat tricky thing to configure in large installations. So you had to tune it down, and then it wasn't high enough for other operations, things like that. It's the same thing. The functionality is the same as maintenance workmem used to do for auto vacuum in previous versions. In fact, if you set it to -1, which happens to be the default, then the system still uses maintenance workmem. But it gives you the choice to control the auto vacuum memory separately from your other maintenance workmem. We got a new parameter called session preload libraries to load plugins. We've previously loaded plugins either with shared preload libraries, which load when you restart the whole cluster, or with local preload libraries, which loads every time you connect. But the limit of local preload libraries is they can only be loaded from a specific plugins subdirectory because any user can load them. So they can only load trusted code. This is sort of a cross-in between these two. It allows you, as a super user, in the config file to specify a library to be loaded for every connection at connection start time. And it allows you to load it from anywhere in the Postgres library directories. So it's just sort of crossover between these two parameters. We got a parameter called wallog hints. What it does, it logs hint bit changes to the val. Did that help anyone? That's pretty much the commit message, I think. It's useful for two things. It's useful for what we call the rewind tool, which are tools that will now probably be safe to use. If you want to back a replica a couple of transactions backwards in order to be able to connect it to a new master. It has still some limitations, but it's at least doable. What it also gives you, it gives you a hint about what's your xlog overhead going to be if you enable checksums. So you know, as of 9.3, we can do checksums, block level checksums in Postgres, but you need to do it at initdb time. And depending on your workload, it can come with a large overhead or a small overhead. This is a good way to actually measure the transaction log part, because this parameter you can change in just restart Postgres. And it adds the same amount of data to the transaction log that the checksums would do. You will also have some more CPU overhead if you enable the actual checksums, but that's usually not your problem. Your scalability problems or performance problems tend to be related to I/O. And this gives you a hint of what... How many of you use pgstat statements today? The rest of you, look at it. You should be using it. It's great. And 9.4 will make it even better. 9.4 will expose what we call the query ID, which is the actual hash value of the query. In pgstat statements, that look exactly the same in pgstat statements, but they're actually different. They can be different because they had different search paths. They can be different because an object was dropped and recreated. But you can't actually tell that from the information in pgstat statements. Now, the pgstat statements could tell that because it knew they were different. It just didn't expose that information to you as the user. Now it does. So there's an internal hash value in a field called query ID, which will uniquely identify this query. Now it's important to know this is not stable across versions. It's based on the parse tree, as we call it. So it's based on internal state of Postgres, which is not the same in 9.3 and 9.4 for a lot of these things. So you can't rely on this to be a long-term stable hash number. It will also be different for the same query on a different platform. For example, things like that. There are some schema modifications that will make it unstable as well. But in general, it gives you a much better view and the reasoning as into why these queries look separate. And when you're tracking queries over time, using a tool somewhere, it gives you visibility into what it's actually doing. Let's take a look at some of the replication and recovery features. Again, we're back to actually doing something in this area after having a bit of a low in 9.3 where we focused on other things. We got a new recovery target. One of those those things, so it's becoming confusing to configure. I think we need to fix the interface for that soon. But right now you have recovery. You can set recovery target XID. You can set recovery target time, recovery target name, and now you can also set recovery target equals immediate, which is the only value you can actually set to the recovery target. The point of recovery target is immediate is to stop restoring your backup. You know, the backup, you take a base backup, you go through the log file. You've had all these parameters to tell you how far to go. This parameter will tell you to go as short as possible. Just get the system up as soon as you can, kind of statement. The typical use case for this is actually being able to use your nightly backup as a snapshot backup. It will recover to just midnight or whenever you took it, plus exactly as far as it needs to go to be consistent. Because if you just restore your base backup and nothing else, your database is not consistent. We don't like that. We prefer them to be consistent. So this will take you as short as possible, meaning you get the system up and running as soon as possible. Maybe if you're building, a reporting slave off your backups or something like that, it'll get your system back up as quickly as possible. We've started logging our transactions to the while at regular intervals, even if your system's not doing noticeable amounts of work. Requires it to know about transaction snapshots from the master. And previously we would only ship this information checkpoint on the master. Records would go over. And the problem is, if you had very long-running transactions only, for example, on your master, your slave could get stuck in an inconsistent state and not actually start up. It would start up, but wouldn't let anybody connect to it. What we're doing now is basically we're just logging a list of running transactions every 15 seconds. Because if you actually are doing anything on your system, logging that every 15 seconds is probably not even going to be measurable. And if you're not doing anything at all, we're not going to log them. If your master is completely idle, we're not going to suddenly make it non-idle. More directly useful feature, we got time-delayed standbys. So you can configure your replication slave to intentionally be behind the master. Normally, we'll try to be as close to the master as possible. In asynchronous, in good cases, you can talk about milliseconds after. But sometimes you might want much more. Say you might want an hour or half an hour or something like this. Why would you want that? Well, it's useful when you do something really stupid on the master, like drop an important table. Normally, what you'd have to do is you'd have to go to your backup. This is 30 minutes. You now have the specific point just before you drop the table, without having to go back and restore completely from backup. If you have a large database, restoring completely from backup, even though restoring with point-in-time recovery-based is fairly fast, if we're talking about a couple of terabytes, it still takes time. This will be much faster, so it's a way to sort of prevent the long downtime for doing stupid things. You probably want to use this in combination with an actual up-to-date replica for the case when the server crashes and you don't want to prevent it from doing anything. It's also worth noticing that it keeps replaying all your normal transaction log. It's just if you have long transactions, you're not going to get a very spiky load. It's going to get reasonably even at whatever delay you set for the time delay. Those are the main things that I was going to go through. There's always more, of course. There's a huge number of small things. There are and there's, of course, a lot of things that are actually in progress. A list now of things that are in progress. Some of them are actually not in progress anymore. But I was at a conference yesterday and on a plane 2 days ago. It's updated as of me leaving the Stockholm airport. It was up to date then, but we're in the middle of a commit fest, so things happen. I don't think anything has been rejected between now and then. So just as a note, we got people working on triggers for foreign tables. and inheritance for foreign tables. You know, that's probably mostly useful because we use inheritance for partitioning. So it would allow you to combine partitioning and foreign tables, which could probably let you do a lot of interesting things. We got some fairly large performance things that are still in the queue. We're looking at some of these reduced lockings for alter table to make that do that. Reduced WAL volume for updates, just decreasing the amount of information in the WAL for certain types of updates, using intelligent compression and things like that. Partial sorting when we don't need to sort everything. We got something called GIN index fast scan because our GIN indexes can apparently be faster than they are. I haven't entirely read up on how it does that, but I think several of these are probably in fairly good shape for getting applied because people have been working on them for quite a while. In the backup space, we're looking at things like backup throttling, being able to make your backup go slower to have less impact on your system while it's running. Being able to relocate table spaces in PG-based backup. Right now, if you use PG-based backup with multiple table spaces, it's a really clunky interface. You might not want your table space to be in exactly the same position on every node. So let you fix that. I know the last one has been applied. PGStat Archiver gives you a view into your log archiving. It tells you how far along the system is and what it does. One of those that we might get, don't get your hopes up too high, it's been debated heavily for a long time, is what we call insert into on duplicate key look for update, or as some people would like to call it, upsert. I like the longer name because, you know, the SQL standard loves it. I don't think it's a SQL standard, the long name. I think that's just Peter, but the SQL standard has merge. This is not merge. It's not all of it. But this is intended to cover the most common use case, which is exactly, you should be able to insert into a table. You can do this almost today because you can say insert into the table, but the problem is there's a race condition. You insert into the table and they say, oh, there's a duplicate, then it's updated, and then somebody has already deleted it. And that's definitely a race condition. That's basically what this thing is trying to solve. And you can combine this with the writable CTE to get upsert. So we will not have the statement upsert, because that's a weird statement. But we will combine it with writable CTEs and the nice keywords of on duplicate key look for update. We might get a shorter version of that. And of course, the feature that everybody's waiting for, right? Not everybody, but a lot of people. We're hoping to see HStore version 2. How many in here are using HStore today? Okay, how many in here know of HStore but just aren't using it? Okay, the rest of you need to go read up on HStore. HStore today is just a key value store in a single column, but it's fully dynamically indexable. You don't need to create an index for every key. You can just search for anything you want. HStore 2 allows us to nest them, so we can have hierarchical storage. We can have a key that points to a value that is another key value store. And it casts directly to JSON. And we're looking at adding a new data type called JSONB, which is binary JSON. But the thing is, it maps directly on top of HStore, so it would give you dynamic JSON indexing, where you don't actually have to declare. Today, if you want to index a JSON field, you have to declare which keys you want to index on and create one index for each of them. With JSONB and nested HStore, you don't have to do that. You just say, here's my JSON, just index it and give me fast access. We don't know how much of it we're going to get. We don't actually know if we're going to get any of it. But if we're lucky, we get all of it. That's going to expand some really, really good on the capabilities of storing, you know, schemaless or dynamic schema, whatever you want to call it, that sort of data, document storage, key value storage. To the point, this is the feature. Some of you have probably seen it. Some of you have been to a Postgres event, the one in Dublin, where the guys went in the evening when everybody else went for beer. Someone had shown them where MongoDB indexing was faster than Postgres, so they went back and fixed that. And the fact is that this one in their benchmarks, obviously this is one benchmark, but it was significantly faster than MongoDB for JSON indexing. We'll see exactly where we go. The big difference between JSON and JSONB, really, from an interface perspective, is going to be if you store a formatted JSON in JSON today in Postgres, it comes back in exactly the same format. Because we actually just parse it, but we store your text. JSONB will be deparsed into pieces and then put back together when you read it back. So it will not have the same indentation or whatever that you were using, but syntactically it will still be the same JSON. tiny favorite. I always try to find one of those. It's like this microscopic patch of like 4 lines that going to make some people so happy. Dynamic library loading is now debug 1.
Yay.
Anyone who's used local preload libraries knows that every time someone connects to your database, it logs every library it loads. Anyone who's ever installed Postgres on Windows, for example, knows that the PL debugger does just this. Well, that stuff is now debug logging as it should be. So that's a lot less log spam for you. It's probably going to help you if you have the problem. If you don't, you're just not going to care. And then I've got one of these. It's sort of just because we're Postgres. We have a patch that now allows us to support year numbers greater than 5 digits in non-ISO formats. Because if you were using ISO format, we already supported that, of course. But if you were using like these weird backwards American date formats or something like that, we actually only supported 4-year dates. Well, now you can have more than 4-year dates. Yay. Ridiculous limits. Like, there was no reason for the limit to be there, so now there is no limit anymore.
Only positive or also negative?
Both positive and negative years. It needs to be within the range of a timestamp, which is going back to, I don't remember, it's 4,000 or 5,000 years before Christ, I think, and 800,000 years in the future, something like that. So I don't think it might actually apply to negative, because timestamp can't store that large numbers. Anyway, those were the features I wanted to go over. Obviously, there is many more. We are currently in the middle of CF4. When that is finished, we'll put out the first beta version. If you want to spend some time building it, please go ahead and download the Git head and try it out. Let us know now what the bugs are, because there are bugs. The earlier you let us know, the quicker we can get them fixed. If you don't want to go through that, when the beta version is out, there will be packages out. There will be packages for all your major platforms, whether you're on Linux or Windows, all of those be out. Please download it, run it with your workloads. Let us know if things don't work. Let us know if things are slower. And, well, let us know if they're better too. But that, and test out the new features to make sure we didn't miss a corner case somewhere. And again, if you can get this testing done before the release, well then, once we get the release, you can just deploy it to production and be happy. Okay, thank you all for showing up. Questions? Okay, then we'll just go for fresh air.
Yeah, Magnus, didn't know you can only delay a standby by 24 days, 20 hours?
Yes, I know. We used to have the same problem with, there's another timing parameter. Yeah, that's streaming standby delay used to have the same problem.
Yeah.
Because it was defined in milliseconds.
Yes.
But now max standby streaming delay is defined in seconds. So that's long enough.
I don't think there's much of a use case for it to be any longer anyway.
No, but on the other hand, I'm not sure there's much of a use case for having the delay defined in milliseconds.
So you're probably
No, there isn't.
Like I want it to be delayed 114 milliseconds. No more than that.
I have no clue about that.
I have to look if Peter fixed the bug. When you change SC messages today,
It's real power though, not
No idea who else is going to be here now.
you have to restart.
Two of you.
Funny.
Because of
Sorry?
SC messages.
Well, now you have the chance to pick.
I know you wouldn't say that if you didn't.
You forced me to spend way too long now talking about
yeah, the background library we don't allow.
and
Still at 9.3 still is not
I was obviously looking at especially how many things that we're using It should be more. But in my experience, it isn't. Like if it's full, getting there. But it's like you make your life so much easier if you use it.
Yeah.
getting there. In the meantime, you have to sound like
I've never needed to
over and over.
Yeah, but it's not possible anymore because of this.
Yes, H-Store is actually pretty awesome even without this.
Come on.
It's going to get better.
So there's lots of to do for me in standardization of SQL.
Next. There's always stuff to do, but I've given up.
What?
I've given up on standardization more or less.
Now you have to convince Oracle to implement IBM. We managed to get limit into it, and also we managed to get.
Yes.
Yeah, because it we get, what was it? Period.
Does MySQL have period?
No, Postgres. But
Okay, yeah.
Peter and me managed to get period in it.
Well, we don't have period anymore.
Okay. It merges, yeah, okay. So, let's go.
So, Postgres performs for humans, that's not for me then.
Magnus, HStore is compatible with the previous.
Yes.
During PT upgrade.
No, so what it's going to be, you're going to need, the way it looks now, I mean it's not committed yet, but the way it looks now is you're going to have to re-index your gist indexes.
Yeah.
The gin indexes will actually be backwards compatible, and the table store will be backwards compatible.
Okay. I'm ready.
I think that was one. Okay.
I'm bound to ask you if it's okay if you recall the record numbers.
Oh yeah.
Do you know who the room host is? Yes, so sweet too. Do you know who the other room host is?
No.
Okay. Go over there and
Is it? I've got 15 more seconds, still 2. Alrighty, hi everyone. I'm Craig Kirsteins. I work at Heroku. Hopefully.